Hello, tree class. Here we are. It's the weekend version. Let me check the date. Should do that before I turn on the video. But November. This is November 6th, so you'll be watching it the evening of the 6th, 7th, or 8th. So I'll just write 11/6. And we are going to look at another kind of equation with trig functions in it to solve. And these are when the angles are multiple angles, like doubled angles or tripled angles, or sometimes halved angles. So I think I can show you this with one or two examples. I need two, but maybe that's all. Let's see. So you're going to start off solving. The command is solve. And you're going to start off pretty much the same as any other equation. Let's say that we have no restrictions on this equation. So I'm going to solve it in the normal fashion to begin with. And I always try to get the trig expression by itself. So I'm going to move the 1 over by addition and the 2 by division. So I end up with cosine of 3t equals 1 over 2. And that is really where the algebra part stops, as I cannot divide both sides by 3 because this cosine is applied to the 3 and the t. It's in the argument. I can spell sometimes. This is called the argument. And it's the only kind of argument we're going to be allowed in my class. So this kind of argument is that to which the function is applied. So the cosine is applied to 3t. 3t is the complete argument. So when it's in the argument, it's like a marriage. It's inviolable. Inviolable because I cannot divide it. So hopefully a marriage is like that in the ideal setting. So argument inviolable, cannot divide. So we want to recognize that this is improper from all that who struck. We cannot divide by 3 to get rid of that. No, no, no. All right, so what we can do is, forget we ever thought of dividing both sides by 3 there. Go back to this step. What we can do is we can say, well, the cosine of something equals 1/2. So this thing, even though it's tripled, has to have a cosine of 1/2. So what must it equal? Well, we do it the same. We look at the unit circle. Let me divide that up into sixths instead of quarters there. So when I do that, alright, this is very bad. Let me start that over. Alright, we're going to divide that in to sixths, actually 12ths. Top half in the 6th and the bottom half in the 6th. There we go. That's a little more respectable. We are going to look at where that happens. I believe the cosine of something is 1/2 right there, and also down here, because that value is 1/2 square root of 3 over 2, and this value is minus 1/2, I'm sorry, plus 1/2 minus square root of 3 over 2. So both of those have a first value of 1/2. So this angle is pi over 3. And we found another answer, so I'm going to actually write it on another line. Let me move this down. Pi over 3. And then the second one here at this point is 5 pi over 3. But we don't really want to know what 3t is. We want to know what t is. So once I have taken the trig function, which means the inverse trig actually function, I actually drew the circle and found the angle, then I can divide by 3. So I could not divide in this step because I hadn't applied the cosine yet. But once I did, and I got the first coordinate here and here, now I can divide. And before I do that, let's do the multiple angles. These aren't across from one another. So to get the next one, by continually adding 2 pi, I go 2n pi, and same for this one. Now I can address finally the 3. So I'm going to divide every term by 3. Look at the craziness, the crazy answer that appears. So now finally I have t by itself, x if you're working in x. I have pi over 3 over 3. So recall when you flip and multiply, that becomes pi over 9. And then this one becomes 2n pi over 3. We can't really reduce that. So that's one answer, which looks very different than what we have been getting, like pi over 9, but that is the answer. And this one is going to work the same. I'm going to divide this one by 3, this by 3, and this by 3. So I get 5 pi over 9, because that's what 5 pi divided by 3 divided by 3, and I flip and multiply, I do get 5 pi over 9, and then 2n pi divided by 3. Alright. So do you see what a tripling the angle does to our answer? So we started with a tripled angle, and we couldn't really adjust for it until the very end, and that created those responses. Let's look at another one. Try 2 sine squared 2x equals 1. Alright, see if you can work ahead of me. Get that one ready. And I say get it ready. Get sine of 2x by itself. Then you can watch what I did. Alright, did yours end up at the same point as mine? I did the algebra and it came out to that. Notice we have an inviolable argument. We cannot divide it up now. So I have to go to my unit circle and figure out where is there a sign that looks like that. And I think we're used to looking at it in the rationalized form. Sometimes it's easier to keep it with de-rationalized, but we're going to rationalize that. And when we multiply by square root of 2 over square root of 2, we get plus or minus square root of 2 over 2. And that looks more familiar. When we go over to the unit circle land, we'll see that that happens here, 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 and here. So at those spots, so I'll darken those. And because this is square root of 2 over 2 and square root of 2 over 2, the second value, second coordinate being the sign, it does match what we want. Over here it will be square root of 2 over 2. Here the second coordinate will be negative square root of 2 over 2, which counts because we have plus or minus, and this one is negative as well. So we'll go with those 4, and those 4 spots, this is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. But we can consolidate this one with this one because it's half a circle away so from each other. So I can just call that, we're working in 2x, so I say 2x equals pi over 4 plus pi n radians. Alright, I guess the professional way is n pi. Alright, n pi. And that will grab this one, we'll grab this one, and then the next and the next. Alright, and then we can start at, another answer is 3 pi over 4 plus, you can see this one is 180 degrees or pi radians away from the other, so that will consolidate those answers. So now that we have taken the sign, we can go ahead and split up this 2x where we couldn't before. So divide by 2, divide by 2, divide by 2 on the first solution, and we get x equals, what's pi over 4 divided by 2? Is it not pi over 8? And then n pi divided by 2 cannot be reduced. So there's one solution. And then the other, we divide this by 2, this by 2, and this by 2. We get 3 pi over 8 plus n pi over 2. All right. Let's look at one itty bitty one that takes a little different twist, but I think you could handle it without me, but I'll just run through it quickly. And that one is 3 tangent x divided by 2 plus 3 equals 0. On this one, we get the same. Instead of having a double, tripled angle, we have actually half of an angle, which is going to work similarly. So get tangent of x over 2 by itself. So you move the 3 over, it becomes minus 3, divide by 3, and we get a minus 1. And we're done that. So we ask ourselves, where's there a tangent of minus 1? So we can't do anything with that. That argument has to stick together. So where is the tangent of an angle equal to minus 1? So it looks like it's going to be one of those quarter positions where you have, if we were looking here, square root of 2 over 2 and square root of 2 over 2. This second divided by the first will be positive 1, so it can't be here. So it looks like it's going to have to be here and here. Down here we'd have a negative divided by a negative, and we will not get the negative at that point. So here and here, you can see that those are generated. This is 3 pi over 4, and this is 7 pi over 4. But we can generate all of those from this one, or both of those from this one, by saying 3 pi over 4 plus, they are 180 degrees apart, so n pi. Now, to get rid of this 2, and we don't divide by 2, since it's already divided, we're going to have to multiply by 2. So we multiply this by 2 and this by 2. So we end up x, where'd it go? Alright, x equals 2 times 3 pi over 4 will give us 6 pi over 4. Or 3 pi over 2 when I reduce it, plus, and 2 times n pi is 2n pi. Alright, I heard my timer go off, so I'm going to end this video, and if you would bring this knowledge with you on Monday, you'll be set to finish our section on solving trig equations. Have a good weekend. Bye.